Hello class, in this video I'll be showing you the derivative rule for the natural logarithm and providing an application of the derivative. Let's begin. In section 12.4, you learned about the exponential function e to the x. And you learned that if f of x is equal to e to the x, then the derivative is e to the x. You also learned the chain rule version. If h of x is equal to e raised to the g of x, then the derivative is e raised to the g of x times the derivative of g of x. Well, what about the inverse of e to the x? What about the inverse of e to the x? The inverse of e to the x is the natural logarithm. And we call that ln of x. You'll never hear me say ln. I will always refer to ln as the natural logarithm. It'll be written as ln of x, but I'll never say it that way. So now that we have the inverse of e to the x being the natural log of x, what is the derivative of the natural log of x? Well, if f of x is equal to the natural log of x, then the derivative is 1 divided by x. For the chain rule version, if f of x is equal to the natural log of g of x, where g of x is a function, then the derivative of f of x is the derivative of g of x divided by g of x. And now that we have these two rules, let's go ahead and provide an example. If the total revenue in cents received from the sale of Q chicken nuggets is given by RQ, while the total cost in cents to produce Q chicken nuggets is C of Q, find the following. So part A asks to find the marginal cost function. And since the problem is asking for a marginal cost function, you are going to find the derivative with respect to Q of the function C. And what is the derivative of C with respect to Q? Well, since this function is linear, the derivative is 102. And that is the marginal cost function. No natural logarithms, no exponential functions, just a linear function. Part B, find the profit function. Okay, so if we read the problem, a profit function is not given. However, we can create a profit function with what is given. And what we know is that profit is equal to revenue minus cost. So I can write the profit function, P of Q, as the following. Now, it's very important that we take the cost function and put a pair of parentheses around the cost function because you want to subtract both terms. If you don't put these parentheses there, the only term that you are subtracting is 102Q. You want to subtract the entire cost function from the revenue function. And when you do that, you'll have the profit function is equal to 51Q divided by the natural log of Q minus 1,000. And notice that the profit function has a natural log. So somewhere along the line, we're going to take the derivative of this profit function and we're going to have to apply the natural log rule. Part C. Find the approximate increase in profit from one more chicken nugget sold when 8 chicken nuggets are sold. So the problem's asking for an increase in profit. And when we talk about an increase in profit, what we're actually measuring is a change in profit. And we measure changes in profit by finding the derivative and evaluating that derivative at certain values of x. That'll give you the change in profit at those values. So I want to find the derivative of p with respect to q. I'm going to start by writing the function out first. And since p is a rational expression, we're going to have to apply the quotient rule. So the derivative of the numerator is 51. The denominator is the natural log of q minus the numerator times the derivative of the denominator. The derivative of the natural log of q is 1 divided by q. All divided by the denominator squared. And if we clean this up a little bit, you may notice that that q and that q divide to give you 1. So what you're left with is the following. And now that we have the marginal profit function, we can measure the change in profit from one more chicken nugget sold, when 8 chicken nuggets are sold. So we're not going to evaluate this derivative when q is 9, but when q is 8. And we can do that on Desmus. So notice in Desmus, I have the derivative on the first line, and I have the derivative measured at q is equal to 8 on the second line. And it looks like 12.731 cents. So the increase in profit when the 9th chicken nugget is sold is, now this is a marginal value, so these are only approximations. So it's approximately 12.731 cents.